Good afternoon, everyone. This is Hasini from Group 330 here to explain about the Joyverse project. Joyverse is a real-time emotion analysis system designed to help the dyslexic children learn more effectively through adaptive educational games. Let us discuss more about this project. So, what exactly is Joyverse? It is an AI-powered system that tracks the facial expression in real time while dyslexic children play their educational games. Based on their emotions, the system adjusts to the different parameters of the game, such as difficulty, themes, and rewards, all under supervision of the therapist. The goal is to make sure that the learning is more engaging and personalized to each children's need. As we all know, the dyslexic children often struggle with the traditional learning methods, and most existing educational games don't adapt based on how the child is feeling. That means that if they are frustrated or if they are feeling lost, the game just continues moving on the same way, which is very frustrating. Therapists, on the other hand, need better tools to track the child's engagement and emotional responses. Joyverse fills this gap by creating a system that adjusts the gameplay in real time while providing the therapist with valuable insight. So, the solution to this problem is creating the Joyverse website, which personalizes educational games by analyzing the facial expressions and the sentiments. This project is built with the transformer models and the merge stack, meaning that it can adjust the game elements dynamically as the child plays. And since the therapists play a key role, the system also ensures that these adaptations follow the best practices for the effective learning. Talking about the data sets and the pre-processing, one of the biggest challenges in emotion recognition system is finding a good data set. Since existing data set of the children emotions weren't accurate enough, we took a collaborative approach of forming multiple teams, and each team contributing a 50 images per emotion, helping us build a reliable data set. We also used face mesh to extract 468 facial landmarks per image. These landmarks are become input features, and we label each input feature with emotions such as happy, sad, or frustrated. We also clean up any incorrect data, verify that the facial expression matches the labeled emotion, and normalize everything to make sure that the dataset is consistent for the training. Let us now discuss about users and their interaction with Joyverse. Joyverse serves two main user groups, dyslexic children and the therapists. For kids, it provides a personalized and adaptive gaming experience. The system tracks their facial expressions and uses the data to tweak the game in real life, meaning that it just decides whether to make the game more easier, more harder, or just more fun. And now on to the therapist. The Joyverse is offers them a AI-driven insights into child emotional state while they are playing the game. Therapist then chooses the theme for the each children's game, and in return they get emotion analysis report which helps them plan better intervention. In a way, it is a win-win for the both of the groups. Let us discuss about the architecture diagram of this project and break down them into chunks. First, we have the front-end components. This is where the user interacts with the system. Here we are using React framework to create a smooth and engaging experience for the kids playing the games. The game also integrates face mesh to track the facial expression in real time. And the transformer model is a core for any of the emotion recognition system. It processes the facial expression data and classifies emotions such as happiness, frustration, or excitement. And API endpoints act as a middleman, making sure that the data flows smoothly between the front end, back end, and AI model. And coming to the Mongo schema and database tier, we store our user data and emotion analytic results using MongoDB, which helps us keep track of how kids are reacting to the different components of the game. And the backend and the middleware is developed via Node.js and Express. The backend is built on Node.js and Express, handling all logic and communication between the different parts of the system. And our AI model runs on a Flask API where it processes images and predicts emotion in real time. And coming to the cloud deployment, since we want the system to be scalable and accessible, we are designed it for the cloud deployment. And coming to the user interactions, dyslexic children interact with the game and get their facial expression analyzed in real time. And the therapist interact with this through a dashboard that provides emotional insight and help them making informed decisions and interventions. And that is the end of this presentation. In conclusion, Joyverse is all about making learning more engaging and effective for dyslexic children by combining AI, emotion recognition, and real-time game adaptation. That marks the end of this slide, and thank you and have a good day.